Today we will do a very simple chapter, that is time, speed and distance. To explain the basic concept in this chapter, let's take an example. So for example, there are two places, A and B, two cities. So there is a distance of 100 kilometers between these two places. Distance of 100 kilometers between these two places. And I'm going on my bike from city A to city B. Okay. So it took me 2 hours to complete this journey. What what is my speed during the journey? I'm assuming here that my speed was constant during the whole journey. So what's my speed? My speed would be 100 kilometers divided by 2 hours is equal to 50 kilometers per hour. So the formula here to find the speed is distance covered divided by time taken during the journey. So you can also write it like time taken is equal to distance divided by speed. Or you can also write it as distance covered is equal to speed multiplied by time. So, so here are three derivations that you should know to solve the question from this chapter. So to explain these three derivations, let's take an example. For example, the distance is, so let's take an example, the distance, so let the distance is equal to 100 kilometers. The speed is constant, is 50 kilometer per hour. So, and the person takes 2 hours to complete the journey. So that's a simple example. So let's come up to the first derivation. If the distance is constant, the speed is inversely proportionate to the time. So if the distance is 100 kilometer and if the speed increases, and if let's assume that the speed increases to 100 kilometer per hour, then obviously the distance can be covered in 1 km. So if the speed decreases to 25 km per hour, the person will cover the distance in 4 hours. So the speed is inversely proportionate to time. So here, if the speed increases, the time taken decreases, and in case the speed decreases, the time taken increases. So let's do the second derivation. If the time is constant, the distance is directly proportionate to speed. So for example, if the time is constant at 2 hours and the speed increases from 50 kilometers per hour to 100 kilometers per hour, obviously the person can cover 200 kilometers in 2 hours. So in case the speed decreases to 25 kilometers per hour, so obviously in 2 hours the person can cover 50 kilometers per hour. So as the speed increases, the distance covered also increases, and as the speed decreases, the distance covered also decreases. So these are directly proportionate. So the last derivation, distance is equal to speed multiplied by time. So in case the speed is constant, In case the speed is constant, the distance is directly proportionate to time. So let's explain in the example. If speed is 50 kilometer per hour, it is constant, and we have to cover 50 kilometers. Speed is 50 kilometers per hour and the distance is 50 kilometers. So we can cover the 50 kilometers in 1 hour. So in case the speed is constant again, in case the distance increases from 100 kilometers to 200 kilometers, we can cover 200 kilometers by running 50 kilometers per hour in 4 hours. 200 divided by 50, that is 4 hours. So as the distance decreases, the time to cover the distance also decreases. And as the distance increases, time to cover the distance also increases. Thus, the distance is directly proportionate to time. And there is a direct relation. If the distance increases, the time taken also increases. So similarly here, if the distance increases, the speed also increases, and here if the speed increases, the time taken decreases, and if the speed decreases, the time taken increases. To solve the questions from time, speed and distance, you should know these basic conversion units. So first of all, 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So 60 multiplied by 60 is equal to 3600 seconds. 1 kilometer is equal to 1000 meters and 1000 meters is equal to 0.6214 miles. So simply 8 kilometers is equal to 5 miles. You should remember this. 8 kilometers is equal to 5 miles and 1 yard is equal to 3 feet. These are the most important conversion units that you should know, that the one yard is equal to 3 feet. 8 kilometers is equal to 5 miles. Okay, so let's convert kilometer per hour to meter per second. 1 kilometer per hour 1 kilometer per hour is equal to 5 over 18 meters per second. So you should know this. And 1 kilometer per hour is equal to, that one is meters. 1 kilometer per hour is equal to 5 over 8 miles per hour. So learn this. 1 kilometer per hour is equal to 5 over 18 meters per second and 5 over, and it is, both of these are equal to 5 over 8 miles per hour. Walking at 5/6 of his usual speed, a boy reaches his school 12 minutes later. Find the usual time to reach the school. So first of all, let me remind you the first formula that I explained to you. That is, speed is equal to distance over time taken. And if the distance is constant, distance is constant, speed is inversely proportionate to time taken. So if the speed increases, the time taken decreases, and if the speed decreases, the time taken increases. So here, what is the speed? Speed at which the boy is going. Speed is 1/5 of the usual speed. The speed is 1/6 of usual speed. And the time taken. If the speed is 5/6 of usual speed, so give a look to this formula. The speed is inversely proportionate to time taken. So if the speed is 5/6 of usual speed, the time taken will be 6/5 of usual time taken. The usual time is 5/1 or 5/5. And right now the boy is taking 6/5 of the usual time. So what is the extra time he's taking? Extra time is 1/5 of usual time. And 1/5 of the extra time, he's taking 12 minutes extra. So 1/5 of usual time, we take x as usual time taken. 1/5 of usual time is 12 minutes. And the usual times comes out to be 12 multiplied by 5. So that is 60 minutes or 1 hour. So 60 minutes is our answer. The boy usually takes 60 minutes to reach his school, and that is our answer. A boy is walking at 13/11th of his usual speed. He reaches 3 minutes earlier to his school than the usual time taken. Find the usual time taken to reach the school. So right now the speed of the boy, the speed, the speed of boy is 13/11th of the usual speed. As I told you earlier, there is a relationship between speed and the time taken. So speed and time has inverse relationship. So if the speed increases, time taken decreases, and if the speed decreases, the time taken increases. So there is an inverse relationship. So if the speed increases by 13/11, the time taken will decrease in the same ratio. So the time taken will be 11/13th of the usual time. The usual time taken. So the usual time taken, let's assume t, usual time taken, is equal to x. So the usual time taken is 13/13, and right now he is taking 11/13. So it's 2/13. So the boy is taking 2/13 of the time, 2/13 of x, less than the usual time. And what is the value of 2/3x? That is 3 minutes. So x is equal to 3 multiplied by 13/2. So it becomes 39 divided by 2. So it is 19.5 or 19 and a half minutes. So 19 and a half minutes is the usual time to reach the school, and that's our answer. So you should also know what is the average speed. So we have a very handy formula for this, that is 2xy upon x plus y, where x and y are the speeds. So x and y are two different speeds for which we want to find the average. So many of the students do like this, that is x plus y over 2, and that is the wrong formula. Never do this. Okay, that so we can derive this formula, the formula of 2xy or x plus y. So let's see. So there is a distance of A and B. A and B are two cities, and that is the distance. A person goes from city A to city B via car, and he goes at a speed of x kilometer per hour, and he comes back via bus, and he comes back at a speed of y kilometer per hour. So what is the average speed? So the The formula to calculate speed is distance over time. So in these cases, what is the distance? Distance is same in from A to B and B to A, that is D. So D plus D. So he covers this distance twice. Once from when he goes from A to B, and secondly when he comes from B to A. So the distance is D plus D. And what is the time taken? So the formula to calculate time is, if speed is equal to distance over time, then time taken is equal to distance over speed. So the time taken is D over the speed is x plus the D over y. So it becomes 2D over x y dy plus dx. So it becomes 2D over d is a common here, y plus x, and takes it above x y. So d is cancelled here. So what comes out? 2xy over x plus y. So that's a formula to calculate the average speed. A, B, and C ran a 1 kilometer race. A can give 40-meter start to B and 64-meter start to C in a 1 kilometer race. How many meters start B can give to C? So first of all, it'll write it as A, B, C. There are these three competitors. When A ran for 1000 meters, B ran for 960 meters. So he gave a 40-meter start to B. And when A ran for 1000 meters and he gave 64-meter start to C. So it comes out to be 1000 minus 64. So it is 936. When A ran 1000 meters, the C ran just 936 meters. So now we have to find when B ran for 1000 meters, how many meters C ran. So simply 1000 multiplied by 936 divided by 960 is equal to 975 meters. So B can give 1000 meters minus 975 meters is equal to 25 meters start to C. And that's our answer. Let's do a simple question. A man is driving a car at a speed of 30 kilometers per hour. He crossed a bridge in 2 minutes. What is the length of bridge? So the simple formula to find the is distance distance is equal to speed multiplied by time. So here the speed is 30 and the time is, if the speed is given in 30 kilometers per hour, you have to convert minutes into hours. So 2 divided by 60, so here it comes to here. So it comes out to be 1 kilometer, and 1 kilometer is our answer. A man drives his car at a speed of 30 kilometers per hour for 2 hours and then 40 kilometers per hour for 3 hours. Find his average speed. So what people will do here, as we know the simple formula to find the average speed, that is 2xy over x plus y. This formula is not applicable in this case. Why? Because the condition to apply the average speed formula was the distance should be same. The distance should be same. But in this case, the person is driving for 30 kilometer per hour for 2 hours, and that is 60 kilometers, and then 40 kilometers for 3 hours, and that is 120 kilometers. So the distance is different, so we can't apply this formula. So let's apply a simple formula, that is speed is equal to distance over time. So the distance is 60 kilometers is this one, and that's this one is 120 kilometers, and the time taken is 2 hours plus 3 hours. So it becomes 180 over 5. So 3 6 36 kilometer per hour is our answer, and that's our answer. So, so what we learn here is we can't apply average speed formula when the distance is different. So apply the average speed formula only when the distance is same. Speed of a train is 60 km per hour. In a minute, how many poles will the train pass if the poles are placed 50 meters apart? So first of all, what is the speed of train? That is 60 km per hour. So while the poles are 50 meters apart. So we need to convert the speed into meters per second. So it is 60 multiplied by 5 over 18. So if we want to convert speed from kilometer per hour to meter per second, we need to multiply it with 5 over 18. So it becomes 50 over 3 meter per second. So that means in 3 seconds the train covers one pole. So in 3 seconds one pole is covered. So the distance between poles is 50 meters, and it covers 50 meters per 3 seconds. In 3 seconds it covers one pole. In 60 seconds it covers 20 poles. That's really simple. So that's 20 poles is our answer. So let's do another question. How much time a 200-meter train will take to cross a pole if its speed is 60 km per hour? Again, we have to convert the speed of the train from kilometer per hour to meter per second. So that's again 560 multiplied by 5 over 18. So that is 50 over 3 meters per second. So the train covers 50 meters in 3 seconds. So the train will cover 200 meters in, I think it's 12 seconds. So 12 seconds is our answer. So that's our answer. You should understand one thing here. If there is a train, and it has to cover a pole, have to pass a pole here. There is a pole. So it will pass a pole after it covers its own length. So it starts like here and it has to cover its own length. That's why we use this formula, and that's our answer. Hope you like this video. You can buy my preparation DVD for bank exams, SSC, and for all other competitive examinations from www.bankexamstoday.com. Call me or just drop me a mail. Thank you.